Right, it's been a while since I've updated my videos, but here's my battery pack as it stands. This nice shapely little box. Oh god, it weighs a ton. Nice little shaped box. Little voltmeter there to indicate the voltage on the battery. My USB ports there for plugging the phone in, or one of my new little USB bulbs. These are 1 watt. What did wish for a bit bigger, but hey, they seem to work. They were cheap enough. We just plug it in. I always get the USB the wrong way around, always. We just plug it in, and there's a brightness. As you can see, it drops down in voltage as we plug it in. Just unplug that so we can actually see what we're doing. Just opening a box now. I still have the solar panels in the 2P 2S configuration for 12 volts at 4 amps, so it's 40 watts. There's the battery pack inside the actual case. As you can see, there's a voltmeter off to the USB meter, down here, along here, to basically the protection circuit here, which stops the batteries from over discharging. It knocks off at 2.5 volts and will knock off the incoming voltage at 4.3 if it was to ever get there. Not that it should ever do because of the unit here. This is basically a DC to DC step down buck converter. The first one sets what voltage limit you want. The second one sets what the charge indicator bulb is to come on at. So if it's at 100 milliamps or 10 milliamps or an amp, it will force the light to come on. It doesn't actually shut off the power, unfortunately. That's done by the fact that the battery is equalised to the incoming voltage because of the first potentiometer. The second potentiometer sets the ampage. Well, it's set to 4 amps because that's the maximum my solar panels give out. It should actually be 3 amps because I haven't got a heatsink on, but nah, it works. We come down here to the chocolate blocks. This is just a quick connect way of connecting the solar panels in. I have here one of the USB charge circuits. Just put a hole in the side and it's just plugged into my computer now, just charging off that. For this battery pack, it's been downsized, so we've now got what? 1, 2, 3, 4, 5, 6, 7. So it's 70 batteries. Each individual cell is 2.2 amp hours. So yeah, 72 times 70, 140. So about 140, 150 amp hour battery pack at 3.7 volt nominal. I have found that the charging my phone every day, running them bulbs at night, the solar panels can't keep up. They're not producing enough power basically. This battery pack itself is, if I remember correctly, half a kilowatt of storage. So to charge that from a flat, I'm going to be talking nearly 2 kilowatt input. So it's never going to charge fully. And as it does get closer to the top voltage of 4.2 volts, it also limits the amount of current coming in as it gets closer to the equilibrium of the incoming voltage and the batteries. So that's my pack so far. Can get a zoom out photo of it. This is just basically if when I go out on the motorbike, I go to rallies and stuff, I've basically got a way of charging my phone and lighting the tent up, so far anyway. I may add other things to it, I'm not sure yet. I may even change it from 3.7 to, say, 12 volts, so it'll be 11.1 nominal, 3 cells in series, the rest in parallel, to give me a top voltage of 12.6. I may use a step-up converter to step that up to a constant voltage of 12 or 12.6, so even though the batteries drop down, the outgoing voltage will remain the same. Or I may just make it into a 4 series, but that means I would have to step up the voltage from the solar panels or wire them 3 series, which means I lose a panel completely. But we'll see how things go. Anyway, this is how it works so far. Hope you enjoy. Cheers.